Today we are going to discuss about powder bed fusion processes. So the powder bed fusion processor used either a laser or electron beam to melt and fuse material powder together. The process sinters the powder in layer by layer. Selective heating sinters different from other processes by way of using a heated thermal print head to fuse powder material together. So this is the schematic diagrams. So by applying the laser beam, the sintering process going on through the powder bed. So heating is also applied through the electron beam. So what is sintering? Selective laser sintering. Sintering by applying the laser, we are using laser sintering. So SLS, the process is called Selective Laser Sintering Process. SLS, it's a rapid prototyping technique that built models from a wide variety of materials using an additive fabrication method. The build media of SLS comes from in the form of powder, which is fused together by a powerful carbon dioxide laser to form a final product. The build media for SLS comes in powder form, which is fused together by a powerful carbon dioxide laser form the final product. The SLS currently has 10 different building material that can be used within the same machine for a wide variety of applications. The SLS process begins like most other RP processes, while the started STL CAD file format, which is exported now by 3D CAD packages. Okay, the models are generated through CAD. It is converted into STL file. The STL file gives the signals to the 3D printing machines. It manufacturing the prescribed format. So how it works, the mechanisms. So this is the schematic view. So the moving laser beam sinters heat fusible powder in corresponding to the CAD geometry model on one layer at a time to build the solid part. After each layer is completed, a new layer of loose powder is spread across the surface. So the layer by layer powders are gradually bonded by the laser beam into a solid mass that forms the 3D part geometry. In areas not sintered, the powders are loose and can be bored out of complete pots. So these are all the schematic view, scanning system, temperature controlled build chamber with the nitrogen atmosphere, power leveling roller, so laser beam for CO2 lasers, so powder bed on fused piston, excessive powder take up. So in the powder, electron CO2 lasers are passed through the building powder material. So the lasers are builded layer by layer. We are creating the CAD model geometry. So as per the dimensions given in the CAD model, the same dimensions are built layer by layer in this system. So here the scanning system, building pot, the same diagram, excessive powder take up. If the powder is lost or any need, excessive powders are taken from the excessive powder take up. So another important diagram. So how it works. A thin layer heat fusible powder is deposited into a part building chamber. The bottommost cross-sectional slice of the CAD part under fabrication is selectively drawn on the layer of powder by a heat generating CO2 laser. The interaction of the laser beam with the powder elevates the temperature to the point of melting, fusing the powder particles to form a solid mass. The intensity of the laser beam is molded to melt the powder by only in areas defined by the pot's geometry, that is CAD model. Surroundings powder remain loose, compact and serves as supports. When a cross-sectional is completely drawn, a additional layer of powder is deposited via roller mechanism on top of the previous scan layer. This preparation, the next layer is for scanning. So step 2 and step 6. So that is these are repeated when each layer fusing to the layer below it. Successive layers of powders are deposited and the process is repeated until the parts is completed. So what are the materials used? Plastic powders, direct metal laser sintering, ceramic powders, glass powders. So finishing the dimensional accuracies, it is compared to SLA, serial lithography, somewhat accuracy. So need support structures, data preparation of SLS, process parameters. What are the process parameters they are going to do? Part bed temperature to be fixed, layer thickness to be fixed, laser powder to be thickness range of 0.1 to 0.15 mm, scanning speed, energy density, then powder shape. These are the parameters you have to fix and give the input signals. So advantages, SLA parts have probably the best surface quality of other RP systems and also highly competitive in dimensional accuracy. Also the latest SLA system have significantly increased the speed at which parts can be produced with the ultimate. Disadvantages, post-processing requirements, supporting structures to be need waiting on the around 6,000 to 8,000 dollars per column. So applications, tooling, rabbit tooling, injection molding inserts, tools and manufacturing, investment costings, jigs and fixtures, boundary patterns. So future trends, increase working volume and several laser heats, automatic recovery for unbounded powder, repeatability of the process. So some melting points. People who are not working in the melting areas, furnace areas, in this selective laser sintering will be worked out. Thank you.